All right, so now we're going to talk about the properties of covalent compounds. All right, so if you'll remember, covalent compounds, covalent solids, they are individual particles. So unlike ionic and metallic, where you have atoms that are all bunched together, but we just usually talk about the single unit of them, but in reality, they're all bunched together. Covalent solids really are just that. So when you see H2O, I mean, that's exactly what it is. And these covalent molecules are attracted to each other through relatively weak interactions that are called intermolecular forces. So what the heck is an intermolecular force? Well, that is the attraction between two different covalent molecules. Okay, so here you see HCl and HCl, right? And so right here, this interaction between the two, that's an intermolecular force. We call them IMFs for short. All right? Now, so intermolecular forces are between two separate molecules. Intramolecular forces are within the molecule itself. So like a covalent bond is an intramolecular force, whereas this interaction between two different molecules is an intermolecular force. So intermolecular forces, or IMFs, they operate as the same premise as everything else that we've talked about. So there is a positive and a negative attraction there, but it's not like ionic where you have a full positive and a full negative. You have partial charges. There are three major types of intermolecular forces. They are London dispersion, dipole-dipole, and hydrogen bonding. You should have heard of hydrogen bonding before. These, again, only occur between covalent molecules. And I have them listed here from the weakest, which are London dispersion, to the strongest, which are hydrogen bonding, which is what water does. So the stronger the attraction between the two molecules, the harder they're going to be to pull apart, which means that the melting point and the boiling point are going to be higher. Here are some examples of covalent solids. Hopefully you already knew this. It's just a bunch of nonmetals, right? So what are the properties of covalent solids? Well, they have very low melting points and boiling points. They're usually gases and liquids at room temperature, which means they've already melted and boiled. They are poor conductors of electricity. And that is all because they're individual molecules and there's no ions or mobile electrons. They have this low melting and boiling point because the only interactions are the interactions between the two molecules, which are IMFs, which again, if you'll remember, those are relatively weak. So again, reiterating the point I just made, low melting and boiling points because all we're talking about is this little tiny IMF between the molecules, okay? And it is important to know that a lot of times we have really, really big covalent molecules that are associated with things like plastics and biological applications like proteins, okay? So those are all covalently bonded, and they interact with other things through IMFs.